In this day and age, I think it's hugely important to figure out how we innovate and how we can innovate effectively. So I want to share some of my thoughts and some of my learnings over 31 years of design and development that I've been involved with here at Kablooey, and share some of the most interesting and fun things that I've discovered about innovation and development in this time period. So here we go, about 20 minutes, and then you guys can get back to fun and festivities. So here we are at Kablooey Design, of course. Most of you are familiar with us. These are kind of the areas that we spend a lot of time, our time in research and invention, design, ideation, prototyping, all of these kinds of things that to us are very creative. They're a lot of fun, and for most of us that work here, it's an outlet for the creative juices that are churning in our heads that wouldn't otherwise get out. So we have to find good ways to funnel that energy, and this is what we do. So what I want to talk about today is the potential that we all have as innovators, or as potential innovators. What's inside of us that we can tap into that can cause us to be an effective innovator. And then I want to hint at a little bit of process too, and how we take those things that we know and understand about creativity and innovation, and how we might start to push them into a process that makes us effective as innovators. So first of all, our potential. Most of us know that we have a left side to our brain and a right side to our brain, okay? I think we're all aware of that. But what a lot of us don't know or understand is that we can tap into both sides of our brain. If you felt like maybe you grew up and you were a very math-oriented kid, you might have thought, I'm a left brain person. And you might have thought you don't have access to the right side of your brain like other very artistic, creative people do. But that's absolutely not true. Studies have been done that I think are very interesting that show how the left and right brain work, and specifically what activities are occurring in what part of the brain when you subject yourself to a certain type of activity. And it's very interesting. Some of these studies have shown that people don't tend to have a stronger right side or a stronger left side to their brains, as we might have thought. Because you use one doesn't mean that one is stronger. It just means you use it more. You choose to use it more. They say that it's determined more connection by connection. That means, our brains operate by having these synapses that occur, these connections that occur. And what you put yourself in front of, the activities that you put in front of yourself, those are what determine what types of synapses and connections you're going to have. And those occur in different parts of your brain. So because our brain is neuroplastic, we can kind of morph that for ourselves. They went on to say that personality types have absolutely nothing to do with one hemisphere of your brain being more active or stronger or more connected. So you can't say, geez, I'm a math person, I'm a left brain person, and therefore my left brain is stronger. That's absolutely not true. So our philosophy here at Kablooey is that anyone can do it. Anyone can be a creative thinker. Anyone can be a creative person. It doesn't matter what your background is or what your personality is like. You can access the right side of your brain. This was made powerfully evident by a study that was done that Sir Ken Robinson talks about in one of the most listened to TED Talks of all time. And there was a 24-year study that was done with children when they were at the age of 4, and then it followed them for 24 years. And Ken Robinson talks about this study, and one of the things that they found over this study is that their research has shown that these kids, they lose their ability to do what he was calling divergent thinking. And divergent thinking can really be thought of as sort of non-linear thinking in a non-linear way. And they identify this as a key component to creativity. So creative thought and creative thinking has to include this divergent thinking, this non-linear thinking. And these kids were losing their ability to do this as they went through our educational system. A prime example from that study is this. One of the things they asked these children to do when they were in kindergarten, 5-year-olds, they gave them a task and said, draw a bird. So these kids were to draw a bird. And this is what one particular kindergartner drew with those instructions, draw a bird. So then they went throughout the course of their week in kindergarten, and they took part in all their other activities, addition and subtraction. And if you all remember kindergarten, you remember saying, here's 10 apples, and if I put a circle around this many, how many are left? And you're learning subtraction, right? So they go through a week of learning and training. And then at the end of the week, they asked these very same 5-year-olds to do the same thing. Said, draw a bird. And this is what that same little boy drew at the end of the week. You can see that his brain was trying to capture what he felt the essence of a bird was in his first drawing, because he was having to create it on his own. The second drawing, he had been shown what a bird was through other means, and he diverted to what he was shown. Now, this doesn't mean we shouldn't be learning subtraction. What it means is what the methods that we're using to educate ourselves as we grow is definitely causing us to lose the ability to do divergent thinking in our heads, which is a right brain, left brain activity. So these kind of results happened after we educated these children, but we educated them in a very linear fashion. It was very linear. But artistic thinking, which is a key component to creativity, it's not linear at all. Finding the most solutions to a problem, I like to call it scattered chaos thinking. I like to think of this big scattered cloud of chaos at the beginning of a project where we don't know what the right solution is going to be, but we're spending time and energy and effort with our minds thinking about 100 different things, and sometimes it seems like a swirling cloud of chaos. But in reality, that's where the genius happens, and that's where you have to have the ability to pull these nuggets out of that cloud of chaos and pull the genius out of it to get very creative solutions. So at the end of that study, at the beginning of the study, when those children were 4 years old, when they were tested, 98% of them could demonstrate divergent thinking. At the age of 9, only 32% of them could do divergent thinking. At the age of 14, 10. And at the age of 25, after they had graduated and more than likely had their graduate degrees, only 2% of them could demonstrate the ability to do divergent thinking. So if you think about the people that are coming out into the workforce, going through this kind of training, and if you understand that in the product development world that we live in, 90% of all new product development efforts fail, you can kind of start to draw some conclusions about what's happening with innovation, creativity, divergent and linear thinking. Now, when it comes to engineering, engineering is really figuring things out. That's what engineering is. There's all different types of engineering, but when you get right down to it, it's about figuring things out. How do we make things work? How do we figure things out? And there's a lobe in your brain that I like to call the figuring things out lobe. And there's an actual name for it, of course. It's a real lobe, but it's on the right side of the brain, and this is the part of the brain that's responsible for creative problem solving. So if you're an engineer or a design engineer or designer of some sort, your job, your role, your duty is to be a creative problem solver. That's what you are if you're an engineer. And here we have the lobe that's responsible for creative problem solving on the right side of your brain, not on the left side of your brain. It's on the right side of your brain. So if we ask ourselves, what have we engineered out of our lives? What have we engineered out of the things that we've learned? Well, if we look at Socrates for an example, Socrates taught what we understand today as philosophy. And there's 4 major branches of philosophy. But when Socrates was in Athens and he was teaching in the gymnasium, he wasn't necessarily teaching a philosophy class. He was teaching life. He was teaching, this is what you need to know and to do in order to be a good contributor to society. And we know that there was kind of 4 major branches to what Socrates taught. There was metaphysics, which is the study of reality. There was epistemology, which is the study of knowledge. There was axiology, which is the study of art and beauty. And there's logic, which is the study of reasoning. So these were all things that were necessary for us to be cognitive, functioning human beings in life. But if you're an engineer and you've gone through your academic career, you've probably been exposed to very little of this. And the art and the beauty, of course, is on the right side of the brain. Those are things that are firing on the right side of your brain. So what we need is we need people who are artists and designers and engineers together, all rolled into one. This is why Leonardo da Vinci is such a great example. You know, this guy was a mathematician, he was an engineer and a technician, and he was also a fantastic artist, one of the most skilled artists of all time. But of course, he was combining these things. He was doing this left brain, right brain thing together. And that's what made him so effective. So what we need and what we try to do here at Kablooey is we need designers and engineers working together as one. Not just an engineering department working together with a design department and they're working friendly. We need people who have an engineering department in their head and who have a design department in their head, and they're doing this simultaneously together, and the two are firing together and working together in their heads. So it doesn't matter what your degree says on it. If you're going to innovate in this world and be effective, you need to be using both sides of your brain like that. It makes us much more effective. So I like to think of it like this. Most often, we think of engineers that their duty is to solve a problem, and engineers' duty is to figure out how to make it useful for humans. But again, if you think about Leonardo da Vinci, you would kind of scratch your head and ask yourself, why would those two things ever be separated? Yet, in most of our academic careers, we don't learn both. We learn one or the other. And this is leading to some of the failure rates. So, what do we do about this? Well, there's some interesting information and studies that are put out by the Institute for Brain Potential, and I love their seminars and reading some of their information. One of the things I learned through some of their studies that they put out is that a healthy brain can laugh, and a healthy brain can get art and understand art, but a diseased brain that has this weakened corpus callosum, which is the thing that connects your left side to your right side, and unless you've undergone a traumatic brain injury, you've got this superhighway between the two that information passes through, called your corpus callosum. If that's diseased or there's agenesis of the corpus callosum, you don't laugh at jokes, you don't get art, you don't understand it. So the hypothesis that I'm thinking of is, does environmental training, in other words, the lack of those things, could it kind of do the inverse, and could it cause an agenesis of the corpus callosum? Because our brain's neuroplastic. That means it changes with workout, like our muscles do. We work out our muscles, they grow. So could we cause agenesis by depriving ourselves of these things? It's possible, and I don't know if any studies have been done. But that part of the brain that's responsible for creative problem solving, it's also the part that gets the joke and does the art that's on the right side, that understands these things. So, what I'm wondering is if we stimulate these things, humor, if we stimulate art, could creative problem solving, an increase in our capacity, follow? And I think that it does. And I think that's why creative people are so unique and funny and creative, because they live in that world. So if you think about it, think about the anatomy of a joke. What is a joke? Okay, a joke is a story, and it's linear thinking. It's building up a set of linear events. A priest walks into a bar, a guy sits down, blah, blah, blah. Step, 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 linear thinking, right? Then you get to the punchline, you deliver a punchline, and it's a non sequitur. It doesn't fit, and then that's funny. Well, they've actually done the brain scan things on people when they're hearing jokes. And when you're building up the joke, step, 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 linear, parts of the brain on the left side are firing, 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 and when they deliver the punchline, there's this pause. For a millisecond, nothing happens in the brain. And then all of a sudden, that particular lobe on the right side that's responsible for creative problem solving lights up with activity, and the person laughs. So what was that lobe doing? It was doing creative problem solving. It was delivered a piece of information that didn't fit with all of the other linear things ahead of it, and it had to find a way to make it fit and make sense of it. So it did it through humor. Creative problem solving. Laughing at a joke is creative problem solving, and it's using that lobe on the right side of your brain. So what can we do about this that would be fun? Well, if you think about how they use humor in systematic desensitization to things that are bad. A person has a phobia of spiders. What do? They'll use humor, and they'll introduce you to spider humor until you get desensitized to it, so you no longer have a phobia of spiders. So could we also do that to ourselves and sensitize ourselves to good? If we expose ourselves to humor, there's a couple of things that happen. For instance, in our brain, when you laugh, you get a increased level of brain-derived neurofactor, BDNF, goes on the rise as soon as you start laughing. And BDNF is a protein, and it's the one that's responsible for the neuroplasticity in your brain. So your brain's ability to change and to morph and to grow is largely dependent on BDNF. It's also the protein that stores information. And if you think about the fact that everything that you do and say and think is 95% memory and habit, then this protein is extremely important for you to be able to just recall things and just do things. So when it comes to creative problem solving, innovation, answers can just be there and you can access them if you've got more BDNF. And then humor makes us enjoy something. Laughter, we get a shot of dopamine release, and dopamine makes us enjoy that and want to do that thing over again. So again, if we increase humor in our lives, as well as artistic things, repeat artistic activities, we could make ourselves more creative people. And this is why I love comics so much, because comic books are a mixture of art and humor, and they're good for your brain. So Calvin and Hobbes, love it. I love what Picasso said, every child is an artist. The problem is how to remain an artist once we grow up. So knowing that our brains can do that, what do we do with that? How can we take that and move that into a process where we innovate? Well, one of the most important things is what Einstein said here. If I had an hour to save the world, I'd spend 55 minutes defining the problem, but only 5 minutes finding the solution. What was he saying? He was saying that it's far more important to understand how the problem is framed. When you fully understand what the problem is, the solutions will start to present themselves to you. You will start to find those, and the creative part of your brain will start to make those connections and pull those solutions out. So he was talking about design research. He was talking about doing some research to understand the problem before you launch into some sort of solution, before you launch into some sort of product or design that we're going to be making. So this knowledge that you gain from this research that you would be doing to learn about the problem, this is power, and this knowledge actually gives you power. It doesn't give you restrictions. This knowledge from design research gives you power to be an innovator. I'm going to demonstrate that right now with all of you as guinea pigs in the room. So here's what we're going to do. We're going to do a short little quiz, and then we're done here. Pop quiz. I'm going to show you a list of random words. I'm going to ask you, what do the words in this random list have in common? Okay, I'm going to give you 20 seconds to look at this list. And I'm not looking for answers. I don't want anyone to shout out anything. I'm actually going to do a count and ask for a show of hands. So, and again, I'm not going to ask for anyone to give an answer. So I'm going to ask for a show of hands of people who think they might know, and I won't call on you to find out. Okay, so that's 20 seconds. All right, now just by a show of hands so we can get a count. How many of you think you might know what those random words have in common? Just raise your hand. I want to get a count. Anybody know what they might have in common? I see 2 back there. Okay. Anyone else? I see another one.
I don't know that I am confident.
3. Okay, that's right. We got 3. So I give this quiz all over the United States. I've given this quiz hundreds of times, and I should be keeping track of the results. But on average, it's always 10% of the people. 10% of the people. So we have 3 that raised their hand, and we roughly have 30 people. So we're right on track. Okay, now what I'm going to do is I'm going to read you that list. So same list, and I'm going to ask you again. So that list was Neil, Hugh, Pierce, Russell, Doug, Cy, Ben, and Jim. Okay? So now, Neil, Pierce, Hugh, Russell, Doug, Cy, Ben, and Jim. Now, by a show of hands, raise your hands again if you think you might, and I'm not going to call on you, but if you think you might know what those have in common, raise your hand. So now we got 1, 2, 3, 4, 5, 6, 7, 8. Looks like we got 9, maybe 10. Okay, so now we have 10. So now we're like 10 out of 30. So now we're up to about 30%. Maybe more depending on some of you thought, but didn't raise your hands. Okay, I'm going to show you that list again. Here's the list that we looked at. This is the exact same list. Neil, Pierce, Hugh, Russell, Doug, Phil, Pete, Cy, Ben, and Jim. Okay, so now if we raised our hands, of course, there would be 100%. Everyone knows that these are all men's names. All right, so what's important about that? Why is that important? Why did we did that? Well, here's why. I asked for a show of your knowledge about a problem by using one of your 5 senses, which was vision. And we got about a 10% collective knowledge in this group, 10% knowledge of the problem. Okay? When we used 2 of your 5 senses, vision and hearing, That tripled, and we got a 30% knowledge of the problem in the group just by using 2 senses. And this is what Einstein was talking about. Design research, understanding the problem, that 55 minutes defining the problem, that's like using a second sense when you launch into some sort of creative endeavor, when you go to solve a problem, when you go to design a device or an object. That's like using a second sense. And that's the 300% power that you get from doing that research first. So I like to think of it in terms of what Henry Ford said. Henry Ford said, if I would have just done what my customers would have asked for, I would have made a faster horse. That's what we would all do if we didn't do that design research. We would just leap right into making a faster horse. But in reality, there's better things out there and there's better approaches for us to take. So these are the kind of things you need to implement when you want to be innovative into your process. And thank you all for listening. Have a fantastic night.